in this video we're going to be doing Calc BC Problem Set number 5. Problems and playlists are in the description below. Let's take a look. Number 1, the function f of x with f of 4 is -2 has derivatives at x equals 4 shown in the table above. Write the third degree Taylor polynomial to f of x centered at x equals 4. So you definitely need to know the pattern for Taylor polynomials. It's the nth derivative over n factorial x minus a to the n. And then you just keep going. So let's write this one down. So I'm going to say that f of x is approximately equal to, because it's not actually equal to, it's going to be the 0th derivative, which is at the value at 4, so it's just -2. And technically that's over 0 factorial x minus 4 to the 0, but I'm not going to write that part. Plus the first derivative, which is -3, over 1 factorial, and then x minus 4 to the first, and then plus going to be the second derivative, so 5 over 2 factorial, x minus 4 to the second, and then plus the third derivative, which is 2, so 2, 3 factorial, x minus 4 to the third. It's a really simple pattern once you have it memorized, so memorize that as soon as you can. Writing these sorts of polynomials, never really an issue. All right, let's take a look at the next one. We want to evaluate the limit as x approaches 3 of 4 to the x minus 2 minus 4 over x minus 3. So there's a number of ways that we can approach this. I'm going to look at this and say, I think this is the limit definition of the derivative. I think that we are finding the derivative of the function 4 to the x minus 2 at x equals 3, right? So it's f of x minus f of 3 over x minus 3, and then we take the limit as x approaches 3. So I just need to know the derivative of 4 to the x minus 2, and then I'll plug in 3 to get the value here. So we're looking for f prime of 3. So f prime of x, the derivative of 4 to the x minus 2 is going to be 4 to the x minus 2 times the natural log of 4. So it's like a to the u is going to be a to the u natural log of a times the derivative of u. So 4 to the x minus 2 times the natural log of 4 times the derivative of x minus 2, which is 1, which, technically you don't need to write, but it's a good idea so that you never forget the chain rule while you're doing these problems. Now we're going to find f prime of 3, which will just be 4 to the first, natural log of 4, and then we're not going to write times 1. And so this just becomes 4 natural log of 4. You could technically rewrite that in a number of ways because of properties of logs. I'm going to leave it the way that it is. Let's take a look at the next thing. All right, sketch a slope field for the differential equation dy dx equals x plus 2y at the 12 points shown. Sketching slope fields is probably my least favorite thing to do in all of Calc BC because it's just not interesting. So we just need to figure out the slope at every point indicated, right? So let's say that x is always 0. If x is always 0, then our derivative is really just dy dx is just 2y, right? So double the y value. So at 0, obviously we're going to get 0. And then, so when you're at 0, 1, x is 0, y is 1. So you just get 2. But how do you draw something with a slope of 2? Well, I put a point there at -1, -1. I'm just kind of aiming for that point, and I draw my little segment. That's kind of all they look for when they're scoring these things. It's is the slope generally right? Because it's very hard to do. So at 0, 2, the slope is going to be 4. So I fake a point down here. I'm going to aim for it. But you just kind of do your best. At 0, -1, the slope is going to be -2. So we're kind of aiming for the point that's at -1, 1. I don't really think I hit that point, but I aimed for it. So that's everywhere that x is 0. You can kind of do this however you want. You could have just done x is -1 and then x is 1. I decided to do this instead. If y is equal to 2, then our slope is always just going to be the x coordinate and then add 4 to it. So when y is equal to 2, so that's up top, we're going to get this and this. This is just my thought process. As I mentioned, I hate doing these, so I'm not going to go through it too much. Try to get the slopes as accurately as possible. I don't think I did a great job, but I did a job. And so we'll get this. So this one should be easiest, right? You just get a slope of -1, a slope of +1. How bad could that be? And then when y is -1, we just get x minus 2. And again, you try your best. So at -1, -1, the slope is going to be -3, which is pretty steep and negative. And then, when x is +1, you just get a slope of -1. So you're aiming for 0, 0. Again, it doesn't look like I hit that point, but I tried. All right, so drawing slope fields, not a big deal, but I wanted to include them in the problem sets because, I don't know, I hate them and I don't like my attitude to influence your education. All right, next. The graph of f is shown above. We're going to let g of x be 1 plus the integral from 2 to x squared of f of t dt. We want the equation of the line tangent to g of x at x equals 1. Okay, so the first thing we need to do is find g of 1. So just using the definition, g of 1 is going to be 1 plus the integral from 2 to 1 of f of t dt. But we know that there's kind of an issue there, right? Because the lower bound is bigger than the upper bound. So we're going to swap the bounds and change the sign. So we will think it is 1 minus the integral from 1 to 2 of f of t dt. Now what we need to do is go to the graph and figure out what the value is there. So I'm just going to draw this vertical line. From 1 to 2, you get a triangle that has a base of 1, a height of 2. So, I mean, it would be a rectangle with an area of 2, so it's a triangle with an area of 1, which is kind of interesting because it means that g of 1 is 1 minus 1, which is 0. Okay, not a big deal. We need to figure out what g prime is. So g prime is going to be the second fundamental theorem. We take the upper bound and we plug it in. That gives us f of x squared times the derivative of the upper bound. So you got to know the second fundamental theorem. It's the derivative of an integral. It's basically the chain rule. So now let's see. We need to find g prime of 1, which I like to show this step where I'm like plugging values in. It's going to be f of 1 times 2. F of 1, we have the graph of f, so f of 1 is just 2. You can see up there. So it's 2 times 2, which is 4. And then we just want to write our tangent line. So our tangent line is going to be y minus 0 equals 4 quantity x minus 1. All right, that's the entire problem set. I hope this was helpful, and good luck.